Hey there, and welcome. Today, we are diving headfirst into the fantastic and, the surprisingly magical world of cube numbers. And right off the bat, no, we're not talking about ice cubes or sugar cubes. We're talking about mathematical cubes. Our guide for this journey is this little character, Cubo, and he's going to show us how simple numbers can transform into these really powerful three-dimensional shapes. All right, so what is a cube number exactly? Well, it's super simple. It's just a number multiplied by itself 3 times. So for example, 2 cubed, you'll see it written as a 2 with that little 3 floating up top, just means 2 times 2 times 2, which equals 8. A good way to think about it is you're figuring out the volume of a perfect cube, where every single side is that original number's length. Now, the first thing you're probably going to notice is how quickly these numbers get huge. The results are what we call cube numbers, and wow, do they grow fast. I mean, 1 cubed is just 1, that's easy. But by the time you get to 5 cubed, it's already shot all the way up to 125. That's the power you get when you're expanding in 3 dimensions at once: length, width, and height. And this isn't just some abstract math theory either. We use cubes all the time to make sense of the world around us. Anytime you need to figure out the volume of something, like how much can a box hold, what's the capacity of a water tank, or even how did they build those incredible worlds in 3D graphics, you're using the power of cubes. They're totally fundamental to understanding the space inside things. Okay, so let's dig into some of the special properties that all cube numbers share. Think of these as the hidden rules that make them behave in really predictable and often pretty fascinating ways. First up, we've got a simple but really powerful rule. If you cube an even number, the answer is always going to be even. And yep, you guessed it, if you cube an odd number, the answer is always going to be odd. There are absolutely no exceptions. It's a neat little shortcut for checking your math. And you know what? The same logic applies to positive and negative numbers. A positive number cubed, well, it stays positive. No big surprise there. But what about a negative one? Let's think it through. A negative times a negative gives you a positive. But then you have to multiply by a negative one last time, which flips the result right back. So the cube of a negative number is always, always negative. Okay, this is where things get really, really interesting. Now we're going to uncover a truly beautiful, hidden pattern, a kind of secret connection between cube numbers and a totally different part of mathematics. Let's start at the very beginning. The first cube number is 1, which is just 1 cubed. Simple enough, right? But this one little building block is the foundation for an absolutely incredible pattern. Okay, now watch this. If we take the next 2 odd numbers right after 1, so that's 3 and 5, and add them together, what do we get? We get 8. And what's 8? It's exactly 2 cubed. Isn't that wild? And the magic does not stop there. To get the third cube, we just take the next 3 consecutive odd numbers, so 7, 9, and 11. Add them up, and you get 27, which is, you guessed it, precisely 3 cubed. This pattern just keeps on going. This table just lays the whole thing out so beautifully. It shows that every single perfect cube can be built just by adding up a string of odd numbers in a row. It is a truly elegant secret just hiding right there inside the number system. Okay, let's calculate a slightly bigger one. 12 cubed. That's 12 times 12 times 12, which equals 1,728. Now, I want you to do me a favor and just burn that number into your memory. 1,728. It's about to become the star of a very, very famous mathematical story. And that story brings us to one of the most famous anecdotes in all of mathematics. It involves 2 brilliant minds and the number of a simple taxi cab. So the story goes that the English mathematician G.H. Hardy went to visit his collaborator, the self-taught Indian genius Srinivasa Ramanujan. When he got to the hospital, Hardy mentioned that the number of his taxi, 1729, seemed like a rather dull number. But Ramanujan, from his sickbed, immediately replied, "No, Hardy, it is a very interesting number." So, what did Ramanujan see that Hardy missed? What was the hidden secret inside the number 1729 that made it so special? Well, here's the first part of the answer. Remember that number I told you to hold on to? 1728? That's 12 cubed. If you add 1 cubed, which is just 1, you get exactly 1729. But this is what shows Ramanujan's genius. He knew
instantly that there was another way. 10 cubed is 1,000. 9 cubed is 729. And if you add those two together, you also get 1729. It is the smallest number that can be expressed as the sum of two cubes in two different ways.
And because of this story, numbers like this are now officially known as taxicab numbers. 1729 is the very first one, the smallest number that can be formed by adding two cubes in two different ways. It's just a beautiful tribute to a moment of pure mathematical insight. So let's just recap our adventure. We've seen that cube numbers are so much more than just calculations, right? They represent real-world volume, they follow these really elegant rules, they hide incredible patterns, and of course, they've given us one of math's most charming stories. And that really is the perfect takeaway. The next time you see a number that just seems ordinary, remember the story of 1729. It might just be hiding a wonderful secret, waiting for an imagination like yours to come along and find it. Thanks for joining me on this one.